Welcome you all to the chapter 10, light, reflection and refraction. Okay, let me consider a room here. Okay, this is a room, and in this room there is a table kept here. Let me consider there is a table which is kept here, and you enter into the room by this door now here, right? And there is a bulb here. Okay, there is a bulb, right? When you enter into the room, you cannot see anything in the room. What you will do? You'll just put the bulb on here, right? When you make this bulb on, immediately you can see the things around. Then what is happening in that room? Let us check it out now here, right? When you switch on the bulb, you can see the table and other things which are in the room now here, right? Okay, what happens? When you switch on the bulb, there is some energy which is coming from the bulb, because until and unless you switch on the bulb, you cannot see anything in the room. Means there is something which made you to see. And what is that source now here? There is nothing but the bulb. Means there is some energy which is coming from the bulb. Okay, what is actually happening here? There is an energy which comes from the bulb and strikes the table, and if you are seeing from here, you can see it, right? The energy which is coming from the bulb strikes the table, and after striking, it reaches your eyes and you can see the table. And what is this energy? And this energy is called as light, right? Okay, what is light? Light is a form of energy. Do you understand? Light is a form of energy which enables us to see the objects around us. Okay, what is light? Light is a form of energy which enables us to see the objects around us, right? There is something energy which is coming from the bulb, hitting the table, and it reaches your eyes, right? So this is what actually happening in a room. When you switch on the bulb, the light, the energy which comes out from the bulb reaches the object, and that object reflects the light and it reaches your eyes, and thus you can see the object, right? So light is a form of energy which enables us to see the objects around us. And another one thing about light is light travels in a straight line. Do you understand? Always light travels in a straight line, right? And another thing what we need to know here is the path traveled by light is called ray. Okay, let us write down here. Another thing, the path traveled by light is called as what we say here? Ray. Whenever I speak about the ray of light, what is a ray? It is the path traveled by light. And the path which is traveled by light is called as a ray. And do remember, light always travels in a straight line. And whenever the medium through which the light travels, then that kind of medium is called as transparent medium, or it is also called as optical medium, right? For example, if I am taking a glass sheet now here, right, you can see the things which is there opposite to that of glass now here. Means the light passes through the glass now here, right? As the light passes through the glass, and the glass is called as transparent medium, right? If you take a wooden piece, you cannot see the object which is there behind it now here, because light cannot travel through that object now here, right? So that kind of objects are called as opaque objects, right? Okay, do remember, medium are of two types, which allows the light to pass through it and which do not allow the light pass through it now here, right? The medium which allows light to pass through it are called as transparent medium, or it is also called as optical medium, right? Which do not allow light to pass through it, they are called as opaque medium. Okay, in short, let me tell you, the light is a form of energy which enables us to see the objects around us, and it always travels in a straight line, and the path traveled by light is called as a ray. Just it is an introduction. What is light? Do you remember? It is a form of energy. Okay, now let us understand much about this light now here, right? Okay, here in this chapter you will be learning about two phenomena of light. One is reflection and another one is refraction. Okay, let me begin with the first one, that is reflection of light. What is reflection of light? Reflection of light. Let me consider what is this now here, right? Okay, now let me consider this is a surface, right? If I am considering this is a table now here, right? This is a surface, and if the light is incidenting on the table, right, this light ray comes from any of the source, right? Let me consider it as a bulb now here, right? The light ray which is coming from the bulb hits the surface, and this is the path traveled by light. And what is that path traveled by light is called? It is called as a ray, and which is incidenting on the surface, that is called as incident ray. Okay, this ray is called as incident ray. It is called as incident ray. And at this point, right, okay, after striking the surface, it moves in this direction. It is reflected back in that medium now, right? So this is also the path of light, and this is called as reflected ray, and this ray is called as a reflected ray. And at the point of incidence, if I am drawing a straight line, and this line is called as normal, right? See, the line which is perpendicular to the surface at the point of incidence, and that line is called as normal, right? Why we need to take that line? Because to calculate what is the angle here, right? So this is the angle which is formed between incident ray and the normal, and that angle is called as angle of incidence. The angle between reflected ray and the normal, and this angle is called as angle of reflection. Do you understand? What is the need of a normal, right? We are imagining a normal line to identify or to calculate what is the angle of incidence and what is angle of reflection, right? So this is called as normal, this is called as incident ray, and this is called as reflected ray, right? And this reflection of light obeys certain laws. Let us check it out. What are those laws in here, right? So the next side heading is about laws of reflection. Let us consider what are the laws of reflection. Okay, there are two laws. The first law states that the incident ray, the reflected ray, and the normal. Okay, there are three. One is incident ray, reflected ray, and normal, right? At the point of incidence, do you understand? Where are these three rays now here? These three lines, they are at the point of incidence. At the point of incidence. Okay, see here. The incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. Do you understand? All these three lie in the same plane. What is the meaning of this? Do you understand, right? Okay, what is the plane? Okay, this blackboard is a plane. If incident ray is on the blackboard, normal will be on the blackboard, and reflected ray will also be on the blackboard itself, right? Do you understand? All these lies in the same plane. There cannot be reflection like this. Incident ray is on the board, reflected ray is outside the board. It is not the case. Do you understand this? Always, all these three are in the same plane. For example, if I am taking this is a plane, let me consider this duster as a plane here, right? If incident ray is on the duster, reflected ray is also on the duster, normal is also on the duster. So in this plane itself, all the three lie here. Do you understand? Always incident ray, reflected ray, and the normal at the point of incidence all lie in the same plane, right? The reflected ray cannot come out of the plane, right? If incident ray is on the duster, reflected ray must be on the duster. There cannot be reflected ray outside the duster, right? Do you understand? That is the meaning of the first law of reflection. That is, the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. Okay. The second is about angle of incidence and angle of reflection. Do you understand? Angle of incidence is equal equal to angle of incidence is equal to angle of what we say here, reflection, right? Always angle of incidence is equal to angle of reflection. Okay, this is an angle here. Angle of incidence is equal to angle of reflection, right? If the light ray falls here, this both angle will be equal now here, right? If you consider this way the incident ray, reflected ray will be like this, right? Means angle of incidence always will be equal to angle of reflection. And one thing what you need to understand here is this law even can be applied to the spherical surface, right? Do you understand? This is a plane surface which I am considering. If it is the spherical surface, if I am considering spherical surface, again these two laws holds good. Do you remember? These two laws holds good for all kind of surfaces, whatever the shape of the surface may be, right? Do you understand? These are the important laws, and by these laws the reflection of light takes place now here, right? Okay, now after understanding how actually the reflection of light takes place, let us understand how is the image formed by a plane mirror. Okay, so one thing what we will be using in day-to-day life is about the plane mirror, right? That is what the reflection of us we can see now here, right? Okay, let me consider what is the image formed by a plane mirror. Let us consider the plane mirror that you see daily now here, right? So let us understand how actually the image is formed in a plane mirror. Okay, let us understand here. This is a mirror. Okay, this is a mirror, and this is the surface now, right? And you are seeing the mirror. Through mirror you can see yourself now here, right? Let us understand what is happening here, right? Okay, for example, there is a small person who is standing here. Let me check it out like this, and the person is like this, and he is raising the hand like this now here. Let me consider this is like this, right? Okay, there is a small boy who is standing here and he is raising his left hand. Let me consider this is the left hand of the person, right? And he is seeing through the mirror now here, right? For example, if you are standing here, right, let me check it out. If you are standing here and you are seeing, for example, if I am considering here, if you are standing here and you are seeing this person here, right? Okay, so for example, let me consider, you can see his image in the mirror. What actually is happening? Do you understand? The ray which comes from here, do you understand? The ray hits the mirror. Do you remember? Always the ray of light comes from the object. Do you understand this, right? Wherever the object may be, the light ray comes from the object now here, right? Okay, how the light ray comes from the object? There is a bulb, right? Bulb falls on the object, and the ray which comes from the object, let me call it as incident ray here for this sake now here, right? Okay, the right ray which comes from the object like this, its incidence on a what we say now here, plane surface now here, right? Let me consider this surface, and this surface, let me call it as a mirror now here, right? Okay, let me consider this is a mirror, right? And you can see the object at this distance. Okay, let me consider the object, the image of this object is like this now here, right? If I'm considering like this, the image is like this, right? If you are seeing from here, actually this gets reflected here, right? So that for example, let me consider this ray is reflected according to the law of reflection, right? According to the law of reflection, this light ray is reflected, right? And you can see that this ray appears to come from this point. And that is why you can see the image of this person, right? If you are standing, you can see both the object as well as image. And how we can see the image? The light ray appears to come from this point now here, right? So this is the image of this object now here, right? So one thing what you need to understand here is the size. Okay, how actually the image is formed. Okay, first of all, let me tell you the characteristics of the image. Image is what we say here, image is erect, right? You can see the image in the mirror in the upright now here, right? Erect, right? The image will be like this, it will not be in the reverse way, right? So what is the image formed by the plane mirror? Okay, what is this mirror? This is the plane mirror that you use at your home now here, right? Okay, what is this image now here? The image is erect, right? Image is erect, and we can call it as this image is a virtual image. Do you understand? What is the meaning of virtual? Because the light ray appears to come from that point, right? It cannot be caught on the screen. If the light ray appears to come from some point, and that kind of image is called as virtual, right? What is the image formed by the plane mirror? The image is erect. Erect means upright, and the image is virtual. It appears to come from some other place now here, right? So that is called as the virtual image. Image is erect and virtual. And another thing is about the size, right? The size of the image, right? The size of the image is equal to the size of the object. Do you understand? How is the characteristic of the image? That is, size of the image is equal to size of the, what we say here, object. Do you understand? The size of the image, right? So this is the size of the image, right? That is equal to the size of the object, right? Both the size are same. There is no change in the height of the object now, right? Size of the image is equal to the size of the object, right? Do you understand? This is object and this is what now here? Image that can be seen in the mirror now here, right? So the size of the object is equal to size of the image. And another thing what we need to understand here is the distance. Okay, do you understand? The distance of the object from the mirror is equal to the distance of the object from distance of the image from the mirror, right? So another characteristic is about the distance. Distance of the object from the mirror is equal to distance of the image from the, what we say here, mirror, right? The distance of the object from the mirror is equal to distance of the image from the mirror. Okay, this distance will be the same. Okay, these are the characteristic of the plane mirror. And another thing what you need to notice here is, if you raise your left hand, the image will raise its right hand, right? Do you understand? If you have, this is what we say, this experience you will be having in front of the mirror, right? If you raise the left hand, it appears that it is raising his right hand. So this kind of inversion is called as lateral inversion, right? Okay, let me tell you, the image is laterally inverted. Do you understand? It is not inverted vertically, it is laterally inverted. Laterally inverted means sidewise inversion, right? So if you raise the left hand, it raises its right hand, means it is laterally inverted, sidewise inverted, not up and down wise, right? Okay, let me take like this. Image is laterally inverted. So these are some of the characteristics of the image formed by plane mirror. Do remember, image is always erect and virtual. Size of the object is equal to size of the image. Distance of the object from the mirror is equal to distance of the image from the mirror, and the image is laterally inverted, right? It is inverted sidewise, so that is called as lateral inversion, right? Okay, this chapter, this was the concept that you have studied in the earlier classes. This section, that is in the class 10, you will be learning how actually the image is formed by the spherical mirrors. Okay, let us check it out. The spherical mirrors now here, right? Let me consider what actually the spherical mirror is. Now, when we discuss about the mirrors, let me go with the spherical mirrors, right? Spherical mirrors. Okay, this chapter will be on spherical mirrors now here, right? Okay, what are spherical mirrors? Let us check it out, right? These spherical mirrors are, so let me consider like this. A spherical mirror is a part of spherical reflecting surface. Okay, do you remember what is a spherical mirror? It is a part of spherical reflecting surface. For example, let me check it out like this. This is a sphere. Let me consider, this is a sphere, right? Okay, let me consider this is a sphere, right? And this is a hollow sphere. Nothing is there inside, right? It is a hollow sphere, and some part is reflected surface, right? Like this, if I am saying in the mirror there is a silvered surface, right? Another one surface is polished surface, let me call like this, and this is a sphere, right? And if you stand beside it, you can see your face, means it is silvered outside. Let me consider like this now, right? Okay, now if I am considering like this, and if you cut this, if you cut the sphere, you will be getting this part, and this part is called as which mirror now here? This part is called as spherical mirrors, right? So what is spherical mirror? Spherical mirror is a part of spherical reflecting surface, right? There is a surface which is reflecting, and the part of a spherical reflecting surface, that is called as a spherical mirror, right? There is a sphere and you cut that sphere, and the part what we get, that is called as a spherical mirror, right? Okay, now this spherical mirror, let me consider like this. This is a spherical reflecting surface. Do you understand? It is a spherical reflecting, what we say here, surface. It is a sphere, hollow sphere, right? If you stand outside, you can see your face, right? Means reflecting surface is outside. Let me consider like this now, right? And if you cut it, you will be getting a mirror, and that mirror is called as a spherical mirror, right? Since it is a part of spherical reflecting surface, that is why this mirror is called as a spherical mirror, right? Here actually these kind of mirrors are not spherical. It is a part of the sphere, right? That is why the name spherical here, right? Okay, this, let me take what are the types of spherical mirrors. There are two types of spherical mirrors, right? The first one is concave mirror. Do you understand? The first one is concave mirror, and the second one is convex mirror, right? There are two types of mirrors, concave mirror and another one is convex mirror, right? What is the meaning of concave mirror? Let me check it out now here, right? Okay, this is a mirror. Let me take this mirror, right? If I am standing here, this is a mirror, right? If you are standing here and if you can see face here in the inside the curve, if you can see face, this kind of mirror is called as concave mirror, right? This kind of mirror is called as concave mirror, where reflecting surface is inside the curve, right? This is a curve, let me call it as a curve, and let me call this is the silvered surface, or it is a wooden, which is the backside now here. Let me take now here. It is a surface, silvered surface, and this is the reflecting surface, right? Reflecting surface is a surface. If you stand in front of it, you can see your face, right? You can see your face from here. So, but if you stand here, you cannot see your face, right? Because the reflecting surface is this side, right? If reflecting surface is inside the curve, then that kind of mirror is called as concave mirror. So, what is concave mirror? Concave mirror is which mirror? It is a spherical mirror in which reflecting surface is inside the curve. Do you understand? Where reflecting surface is inside the curve, right? Inside the curve is like this. So this kind of mirror is called as concave mirror. Simple. What is concave mirror? Concave mirror is a spherical mirror in which reflecting surface, from which you can see your face now here, right? The reflecting surface is inside the curve, right? If you can see here, then that kind of mirror is called as concave mirror, right? There is another one mirror called convex mirror. Okay, let me consider like this. This is like this, right? And if you're standing here, okay, this is one part now. Let me go with the second part, right? If you're standing here, you can see your face outside the curve, right? If you stand here, you cannot see anything, right? Let me take like this. You cannot see anything. If you stand here, you can see your face. But if you stand here, you can see your face, right? The reflecting surface is, there is a curve. Of course, it is a curve, but the reflecting surface is outside the curve. Okay. This kind of mirror is called as convex mirror. Okay. Once again, what is convex mirror? Convex mirror is a spherical mirror whose reflecting surface is outside the curve. Outside the curve. Do you understand? Whose reflecting surface is outside the curve. You can see your face from this side. The reflecting surface is outside the curve. Then the name is called as convex mirror. You can remember it simple like this, right? Concave, right? Whenever you think about the cave, right? Cave means something is there inside, right? Cave is always which is present inside, right? There is something, some animal is there in that cave, let me call like this, right? Cave, whenever we think about cave, means something must be inside, right? In the similar manner, when we think about concave mirror, cave means something should be inside. What is that something? Reflecting surface, right? If reflecting surface is inside the core, if I am taking like this, and you can see, if you are standing here, you can see your face, the reflecting surface is inside, then this kind of spherical surface is called as concave mirror, right? If you are standing this side and if you are seeing your face, then this kind of mirror is called as convex mirror, right? If reflecting surface is inside, then it is called as concave mirror. If reflecting surface is outside, then it is called as convex mirror, and inside, then it is called as concave mirror, right? Once again, what is concave mirror? Concave mirror is a spherical mirror in which reflecting surface is inside the core. Convex mirror is a spherical mirror in which reflecting surface is outside the core, right? So do you understand? So these are the differences between the concave and convex. There are two types of spherical mirrors, concave mirror and convex mirror. Okay, till now we discussed about three mirrors. One is plane mirror and other two are the spherical mirrors, concave and convex. And before we go with the terminologies, before we go with the image formed by spherical mirrors, let us understand about the terms what we use for the spherical mirrors. Okay, so let me take like this terminology, or let me call terms related to spherical mirrors. Okay, let me take a spherical mirror and let us understand what are the terms related to spherical mirrors. Okay, if I am taking the spherical mirrors, and what are the terms related to that, right? Okay, for example now here, right? Now what I will be doing, I will be considering this sphere, because spherical surface, let me consider a sphere, and this is a surface and whose reflecting surface is inside. This is the center, right? This is the center of the sphere, right? This kind of mirror, right? So you cannot see anything from outside, you can see only from the inside. So this is called as what we say, concave inside, right? So this is called as concave mirror. Okay, let me consider the spheres, the same thing here, right? Now let me consider like this, and let me consider the sphere so that I can relate these two together here, right? This is a sphere, this is the center of the sphere, and this is the core. Let me consider. Now here, if you stand outside, you can see, but you cannot see anything from inside. Let me take like this. You cannot see anything from the inside, right? So you only can see from the outside. So this is called as convex, what we say here, mirrors. So once again, what is a spherical mirror? Do you understand? Whenever I think about spherical mirror, I think about the sphere first, right? What is spherical mirror? It is a part of spherical reflecting surface. It is also part of spherical reflecting surface, right? So spherical mirrors, whenever I think about the spheres, right? Okay, what are the terms related to this mirrors now, right? Whenever I think about the mirror, the first thing what comes to our mind is about the pole, right? The pole, right? So where is the pole? This is the reflecting surface of the mirror. Exactly at the center, this point is called as pole. That is P. It is noted by P, right? And for this convex mirror, yes, here it is a pole. So what is a pole? Pole is center of mirror. If this is a mirror, the center of a reflecting surface of a mirror is called as a pole. Right? Simple. What is pole of a mirror? What is pole? Pole is center or midpoint of a reflecting surface. Reflecting surface of a mirror, of a spherical mirror or a mirror. Okay, center of reflecting surface of a mirror is called as a pole, right? So let me take center of reflecting surface of a spherical mirror, right? Okay, let me take like this. This is a spherical mirror and center of mirror is called as a pole. Do you understand? Pole is the center of the mirror, right? Center of the reflecting surface of the spherical mirror. This is a mirror, this is a reflecting surface, and exactly at the center, that is called as a pole, right? Okay, now let me go with the next one, that is center of curvature. center of curvature. Whenever we speak about the mirrors, we will be using this kind of words, that is center of curvature, and we denote it by capital letter C. What is center of curvature? Name itself says center of curvature. Center, first of all, do understand, that's why I told you spherical mirrors. Whenever I think about spherical mirrors, I think of the sphere. What is center of curvature? It is the center of a sphere. Do you understand? It is the center of sphere. What is the center of mirror called as? Center of mirror is called as pole, right? The center of mirror is called as a pole. That is center of reflecting surface of mirror is called as a pole. Now, what is center of curvature? It is the center of the sphere. Do you remember? It is always outside the mirror now here, right? Okay. It is on the mirror itself, right? But it is outside the mirror. What is center of curvature? It is center of sphere of which mirror is a part. Mirror is a part. Okay, do you understand? Center of sphere of which mirror is a part. Okay, this is the concave mirror and this is a part of the sphere here. The center of sphere of which mirror is a part, that is called as center of curvature, right? So, and it will be denoted by C. Okay, for this again I completed the sphere and the center of sphere, and that is called as center of curvature. Do you understand? It's simple. It is a center of sphere of which mirror is a part. We always know that spherical mirrors are always a part of the sphere. Center of sphere is called as center of curvature. For example, if I want to find what is the center of curvature of this mirror, first I continue and complete the sphere. When I complete the sphere, I get a center. And what is that center called? That center is called as center of curvature. Right? Do you understand? So center of curvature, and we denote it by C. Right? And another one thing what we will be discussing about this is about radius of curvature. And it is a radius of curvature, and we denote it by capital letter R. Do you understand? Center of curvature is in front of the mirror here, but the center of curvature is behind the mirror in case of convex mirror, in front of the mirror in case of concave mirror. Okay, now let me go with the radius of curvature. Simple. This is center of curvature, this is the radius of curvature. So radius of what? Radius of sphere, right? Simple. Nothing is difference between these two now here. Here center of sphere, and this is what now here? It is a radius of sphere of which mirror is a, what we say here? Part. Radius of sphere of which mirror is a part, and that radius is called as radius of curvature. Then what is the radius of curvature here? This is the radius of curvature, right? So this distance is called as radius of curvature. This distance is called as radius of curvature. This distance is called as radius of curvature. So what is the radius of curvature? Radius of sphere, right? This is the radius of sphere. This is the radius of sphere of which mirror is a part. Right, that is called as radius of curvature. Simple. Okay, we have studied about three terminologies. What is pole? Pole is center of mirror. What is center of curvature? It is center of sphere of which mirror is a part. What is radius of curvature? Radius of sphere of which mirror is a part. Means these two are the terminologies which are related to the sphere, right? Pole, it is present in the mirror now here, right? So this center of mirror, this center of sphere, this radius of sphere. So after understanding the three terminologies, let me move ahead now here, right? Okay, so these are the three terminologies that you need to know: pole, center of curvature, and radius of curvature. Let us go ahead now here, right? So when we go ahead, let us take other two terminologies. Before I take the two terminologies, let us understand something new now here, right? Okay, for example, this is mirror here, right? Let me consider like this, and reflecting surface is inside. Okay, here you cannot see your face, right? This is the reflecting surface, right? We came to know that what is the center of mirror called? It is called as a pole, right? Okay, whenever I want a center of curvature, what do? I need to complete the sphere first. Okay, let me complete the sphere. I have completed the sphere. Okay, when I complete the sphere, I get a center of sphere. And what is that center of sphere called? Center of curvature. That is called as center of curvature. And after that, I will remove this. Just it is an imagination. I will be removing it because this is a part. I want only the mirror, right? So in order to calculate what is center of curvature, I need to imagine a sphere first. And the center of sphere is called as center of curvature, right? Okay. Now, One thing what you need to understand here is there is a line which passes through center of curvature and pole, and this line is called as principal axis. Do you understand what is principal axis? Principal axis, right? Do you understand? Axis is nothing but a line. Principal, main line. Okay, let me consider like this. What is the principal axis? This is a line, right? Okay, let me write what is principal axis. It is the line passing through. Let me take like this, line passing through. Line passing through. What is this now here? Center of curvature. Center of curvature and what is that now here? Pole of the mirror. Pole of the mirror. The line which is passing through center of curvature and the pole of the mirror, that line is called as principal axis. Do you understand this, right? This is the fourth terminology what we are studying, right? What is principal axis? Simple. First of all, do you understand? Whenever we speak about axis, axis is a line which passes through the center of curvature and the pole, and that line is called as principal axis. For example, this is the principal axis. Now let me consider like this. This is a concave inside and the reflecting surface is also outside. Let me call it as what we say here, convex. This is a concave mirror and this is what we say here, convex, what we say here, mirror, right? So do you understand what is principal axis? It is a line which passes through the center of curvature and pole, right? It is exactly cuts the center of the mirror here, right? So that line is called as principal axis. Now let me go with the next terminology, right? Before I go with the next terminology, let me write something about convex mirror. What is convex mirror? First, what I need to do? It is a part of the sphere. I need to imagine a sphere. Okay, let me imagine a sphere. First of all, let me imagine a sphere. If I imagine a sphere, I get the center of sphere, right? Center of sphere. And what is that center of sphere called? Center of curvature. Now I don't want any spheres like this, right? I got center of curvature and the center of the mirror, what it is called now here? It is called as a pole. And the line which passes through pole and, sorry here, let me take here, right? Here, the center of curvature, and this line is called as a principal axis. Do you understand? That is called as a principal axis, right? Okay, now what I will be doing, do you understand? Whenever I take the object at a far distance, the light rays which come are always parallel. Do you understand this, right? If the objects are far at an infinite distance, the light rays which are coming are always parallel to the principal axis. Okay, let me consider like this. There is a light ray which falls here. This is the incident ray. Do you understand? This is the incident ray, right? It falls on the mirror here. Come on, tell me now. If it falls on the mirror, right? And after completing, it falls on the mirror and it follows this path. Let me take like this. It follows this path, right? It comes here, it hits and it follows this path, right? Okay. And before I go with the this section, you need to understand if there is a plane surface. Come on, tell me. If there is a plane surface, where do you draw the normal? Normal for this point. If I want a normal, I will be drawing a line which is perpendicular to the surface, and this surface is called as what we say here, normal. For which surface here? Plane surface, right? For example, if I am taking a curved surface like this, okay, where to draw the normal? That is the thing, right? So if I am taking this curved surface, do understand, if I am taking a curved surface, I need to complete this. I get a center of curvature, I remove this. At this point, if I want to draw the normal, where actually I need to draw the normal? The normal always passes through the center of curvature, and this line is called as normal. Do you understand this, right? This is the thing what you need to understand. If it is a plane, okay, normal is perpendicular to the plane. If it is a curvature, normal is a line which passes through center of curvature. Okay, let me understand. After understanding this, let me tell you why actually the ray passes through here, right? Okay, first of all, let me take like this. Okay, first understand here, this is the incident ray which falls on the mirror. If an incident ray falls on the mirror, it must obey law of reflection. Okay, let us check it out. At this point, I need to draw the normal. Shall I draw this? I need to draw the normal, and this line is which line here? It is a normal. Normal is a line for a spherical mirror which passes through center of curvature. Okay. This is what now here? Incident ray. This is what now here? Normal. And what is this angle? This angle is called as angle of incidence. Now come on, tell me now here, where actually the reflected ray must be? It should come inside or it should go outside? It should come this side, right? Because angle of incidence must be equal to angle of reflection, right? Okay, means it must pass through this point itself. Why? Because this angle is angle of reflection and angle of incidence must be equal to angle of reflection, right? It obeys law of reflection, right? Don't understand. That is the reason why this light ray converges at this point now, right? Okay. In the similar manner, if I am taking a ray which is like this, it also after reflection pass through this point itself, right? If the ray falls on the pole here, it retraces its path. It retraces its path like this, right? Again, if I am taking a ray of light like this is a ray of light, incident ray, right? If it falls here and again if I take a normal and the reflected ray will pass here at this point, right? Let me take like this. And if I take the incident ray like this, it hits the mirror like this and after reflecting it passes through the same point, right? It converges at a simple this point now here, and this point is called as principal focus because all the reflected rays focus at a point. That is why the name called principal focus, because it falls on the principal line, right? So this is called as a principal focus. What is principal focus? Here parallel rays of light after reflection meet at a point. That point is called as principal focus, right? Do you understand this? Right, now let me go with the convex mirror now here, right? Okay, let me take this as a convex mirror and let me take the same ray like this. This is the incident ray. Come on, tell me now. It cannot go inside because this is not a reflecting surface, only this surface is reflecting surface. It must bounce back now here, right? It must go in this direction. The next question arises here is, will the light ray comes this side or the light ray goes that side now here? It depends upon normal. Okay, where is actually the normal? Normal is a line must pass through center of curvature. Where is center of curvature? This is center of curvature. Through this you need to get a normal. If I get a normal, what is this now here? This is angle of incidence. Okay, where should the ray should go? Ray should go in such a way that angle of incidence must be equal to angle of reflection, right? Okay, means the ray should go like this. It should go like this because angle of incidence is equal to angle of reflection, right? This angle must be equal, right? If I am taking like this is a ray which goes like this and this is an angle of incidence must be equal to angle of reflection. That is how it obeys law of reflection, right? Okay, so this, just to understand why the rays will go in that direction itself, to understand this I have drawn, and this appears to come from this point, right? Okay, now if a ray of light falls here, again it goes like this now, right? It goes in this, because if I draw the normal, it should move in that way itself, and if a ray of light falls exactly at the pole, it reverts back, right? If I am taking a ray of light which falls here, and it must reflect in this way itself, right? If I take a ray of light here, it must reflect here, and it appears to come from this point, and this point is called as principal focus. Do you understand this, right? For this, here the principal focus is this, and here the principal focus is here. This is concave mirror and this is a convex mirror, right? So now what we are understanding, what is principal focus. The next one is about principal focus. We are understanding what actually the principal focus is. Do you understand? Principal focus is a point. Do you understand? It is the point. Where actually is the point? Point on the principal axis. Principal axis. Do you understand? This is a point. This is a point. That point is on the principal axis. Let me write. What is principal focus? Principal focus is a point. Principal axis was a line. Principal focus is a point. Where is that point? On the principal axis, right? Principal axis. What is principal focus? It is a point on the principal axis where where the rays of light parallel to principal axis, where the rays of light parallel to principal axis meet or appears to meet after reflection, right? Meet or appears to meet after reflection from a spherical mirror, so that point is called as principal focus. Simple. Okay, first of all, what is principal focus? Principal focus is a point where actually the point is on the principal axis, where the rays of light parallel to principal axis meet or appears to meet after reflection from spherical mirror, right? First of all, do you understand? Meet, where actually they meet in case of concave mirror, they appears to meet in case of convex mirror. There are two cases here. Meet I use because when I use the concave I will be using the word meet. Appears to meet, that is convex, so I need to combine both, so let me write both now here, right? So the rays of light parallel to principal axis, okay, from where you get the parallel rays of light, if the object is too far, the rays what we get are the parallel rays, right? Okay, where the rays of light parallel to principal axis meet or appears to meet after reflection, right? They meet or appears to meet after reflection from a spherical mirror, and that point is called as principal focus, right? Okay, now there is another one terminology called focal length. Let me call it a small letter F. Focal length, again simple. Length again is a distance, right? What is focal length? This is the distance. This distance is called as focal length. Focal length is the distance between principal focus and pole, right? Simple. What is focal length? It is the distance between, what is distance between? Principal focus. Distance between principal focus, right? That is why the name focal length, right? The distance between principal focus and pole of the mirror The distance between principal focus and the pole of the mirror, that distance is called as focal length. Simple. And here also, where is focal length? So this distance is called as a focal length. What is this distance called? This distance is called as radius of curvature, right? So this distance is called as focal length. Do you understand this, right? So focal length is the distance between principal focus and pole, and this distance is called as focal length, and this is the focal length of the mirrors now, right? Okay, so principal focus and another one is focal length. Okay, now after studying this principal focus and focal length, let me tell you another one terminology which is related to a spherical mirror, and that is called as aperture. Okay, let me call what is aperture, right? What is aperture? What is aperture of a mirror, right? When you go to the market and if you ask convex mirror or a concave mirror, they will ask how much aperture do you want? Do you want a bigger aperture or do you want a smaller aperture? So first of all, let us understand what actually the aperture is. Aperture, first of all, do understand it is a diameter. Do you understand? Principal axis is a line, principal focus is a point, aperture is a diameter, right? It is the diameter of reflecting surface of a mirror, of a spherical mirror, Do you understand? Diameter of a spherical surface. For example, this is a let me take this is a concave mirror here, right? If you see the concave mirror, this side appears to be a circle. This is a circle, and if I draw the diameter, that is itself is called as aperture. Do you understand, right? So diameter of a reflecting surface. If I am taking this is a concave mirror, and if I am seeing this side, I get a circle now here, right? So the diameter of the circle, this is the reflecting surface, and that diameter itself is called as aperture. aperture. Do you understand, right? So if you go to the market, you will be getting this much aperture, larger aperture and smaller aperture. This is called a smaller aperture, this is called as a larger aperture, right? If you want a small mirror, you will be getting this much kind of mirror, and you will get this much kind of mirror, right? So if you want a bigger mirror, you say that, okay, I want a bigger aperture. So what is aperture? It is a diameter of a reflecting surface of a spherical mirror, and that diameter is called as a aperture, right? Do understand, this is the name, aperture. Aperture is nothing but diameter, right? Okay. Now if I am taking a note point, let me take a note point. What is the relation between radius of curvature, that is R, and focal length, that is F, right? What is the relationship between radius of curvature and focal length? Do you understand? Relation between radius of curvature and focal length is R is equal to, how much is R? Do remember, it is always double of F. Do remember, radius of curvature is always double of F, right? If this is radius of curvature, this is half of that, right? Okay, by this I can say like this, F lies exactly at the midway between pole and center of curvature, right? Therefore, shall I say like this, principal focus, where does it lie? Principal focus lies at midway between, what? Pole and center of curvature. Midway between pole and center of what we say here, curvature, right? Do you understand? It is exactly at the midway, right? It's simple now here, right? If I'm taking a mirror, I complete the sphere, I get center of curvature, exactly at the middle I can draw the principal focus, right? By this I can say that principal focus lies at the midway between pole and center of, okay, now come on, tell me, this is focal length, and what is this now here? Radius of curvature. How much is radius of curvature? Double of that focal length. And this principal focus lies exactly at the midway between center of curvature and the pole, right? So these all are the terminologies what we use for the spherical mirrors. Let me summarize all the terminologies and complete this session here, right? Okay, now do understand. For example, let me take a concave mirror now here, right? And let me understand here, let me tell you, this is, shall I take like this? This is which mirror now here? Concave mirror. What is concave mirror? Reflecting surface is inside the curve. Cave, right? Inside the curve, right? So this here you cannot see anything. You cannot see, right? So this is the reflecting surface. This is called as reflecting surface. First of all, terminology. First terminology, pole. Where is pole? Center of mirror. Simple. What is center of mirror? This is center of mirror, and this is what we say here, pole. Next, what do I want? I want center of curvature. To find center of curvature, what I need to do? I need to imagine a sphere, right? Okay, first of all, let me imagine a sphere, right? I have imagined a sphere. Where is center of sphere? This is center of the sphere, right? And this point is called as center of curvature, and I will be removing this. Did you understand this, right? Whenever I need to find center of curvature, I need to imagine a sphere. Why? Spherical mirrors are always a part of a spherical reflecting surface, right? I got center of curvature. Next, I want a principal focus. We have already studied that. Okay, what is this line called? The line which passes through center of curvature and pole, that is called as a principal axis. If this is center of curvature, exactly at the midway, what is present? Principal focus that we have learnt here, right? Principal focus is always at the midway between pole and center of curvature. And what is this distance called? This distance is called as a radius of curvature, because radius of sphere of which mirror is a path. And what is this distance called? This distance called as a focal length. Distance between principal focus and pole. And what is the relation between R and F? R is double that of F now, right? R is equal to 2F, right? So this is focal length, and this is radius of curvature, principal focus, center of curvature, and this is the pole. So these all, and another one thing which is left out is aperture. What is aperture? The diameter. So if I am taking, this is a three-dimensional, if you imagine, there is a circle and the diameter. And what is this diameter called? Diameter, that diameter is called as aperture. aperture of a mirror. So these all are the terminologies that we use in case of a spherical mirror. Right. So in the next session we will be discussing how actually the image is formed by the spherical mirrors. So before that, you need to understand what are the terminologies that we use for spherical mirrors. Thank you.